How's it going, everybody? In this video, we're going to be pretty much wrapping up the external connections aspect of things. And one of the things that I was doing while I was doing some additional testing and things like that, we had some issues in the previous video where one of our switches decided to flake out and not want to work and things like that. So I was able to resolve all those issues. And so as I was going through and getting the additional eBGP peerings online and getting all that stuff squared away, I was trying to figure out why the route updates that I was expecting to see on the other leaf switches. So 9K3 and 9K5 are both terminating eBGP connections to the MPLS service provider. That's all well and great. But for whatever reason, I could not get the PC that was acting as an external endpoint. I could not get that PC or that router inside the VRF to be able to communicate to any of the endpoints that were attached to 9K1. I could ping 14 and 20 all day long, and that wasn't a problem. I'm like, what am I missing? So I started digging into it, and it was one of those things where, I've been dealing with BGP for a really long time. Excuse me. So I decided to do some debugs on it to see what was going on, and one of the issues that I realized was that the updates that I was receiving in, when I would do a clear BGP soft, I would see that the update was coming in, but it was being dropped due to an attribute error. It wasn't specific as to which attribute, but when I looked into the specifics of it, I realized that the update was coming from an IP address that the updates were sourced from. So when we're dealing with VPC and VXLAN at the same time, 9K1 and 9K3 were running in a VPC, and they had a VPC 10 that was connected down to switch 8. And I was like, okay, how do I fix this? And I wasn't sure at first, but I was like, there's got to be something here for me to, it's going to work. It has to work. So I monkeyed around with it for a little bit. And as soon as it dawned on me that the update IP address, or the source IP address, so when a BGP update comes in, the network layer reachability information, NLRI, the route information itself, is going to have a source IP address attached to it. Now, 9K3 and 9K1 are both peer to the upstream spines, and then they are connected to, from the spines down to the remote VTEP. And normally with route reflection, it's not that big of a deal. It's automatically going to accept the routes in and then propagate them downstream. And I was like, why is this not showing up? And it didn't make a lot of sense to me. I was having a hard time figuring that piece out. And after I monkeyed with it for a little bit, I realized that they were both, 9K1 and 9K3 were both coming from the same source IP, 10.0.0.13, which happens to be the Anycast IP address that's set up on the loopback interfaces, loopback 0 specifically, on both leaf switches, so that when they're in a VPC peer together, the updates look like they're coming from both devices, because they're doing chassis aggregation. They're acting as one logical unit. I was like, oh, well, that makes sense. And as soon as I realized that, I went ahead and I broke the VPC. I shut it down, and then I had to go and turn off the VPC peer link, the port channel 13 that I'd set up between 9K1 and 9K3. So I went underneath VPC domain 13 and I shut it down, just typed in the shutdown command, and then underneath port channel 13, I simply shut down that link, which shuts down the port channel that's sitting between 9K1 and 9K3. So as soon as I did that, then I had to go and I deleted the interface IP address, the secondary, the 10.0.0.13/32 secondary address. I deleted that on 9K1 and 9K3, and then I flapped the loopback, so shut that, and then I went underneath the NVE interface and I flapped it. And the route still wasn't propagating, and I was like, what is going on here? And I was like, okay, now I'm like struggling, because I figured that would have fixed the problem, and it didn't. I'm like, okay, what else could be the issue? So I started looking at it, And I had to start looking back through my notes. I got to the point where it's like, okay, I know how BGP works. What is it that I'm missing? And I went through and I was like, some notes that I had taken from some labs that or some blogs and some books that I've read that cover this particular topic. I was like, it's got to be something specific to the propagation of the routing information. So I went ahead, and because it was underneath the IPv4 unicast address family, I thought, well, maybe I need to have the IPv4 unicast address family turned on between the leafs and the spines. So I went ahead and I turned that on, and I did the route reflector client thing on the spines down to the leafs. I got all that squared away. That didn't fix it. I'm like, okay, what am I missing here? I would see the route showing up in the BGP table, or in the BGP table, and I'm like, okay, what am I missing here? So that's when I went back to the book, and I was missing a piece where, in order for the routes to get propagated, they need to be redistributed to BGP, which I thought was like, but I'm already doing that. So I went ahead and I did that. I redistributed underneath the VRF. I redistributed the subnets that are directly connecting 9K3 to PE1, and so that's going to be for per VRF 10.101.11 and 10.101.12. I went ahead and I did redistribution with that, and as soon as I did that, 9K1 triggered, and I got BGP updates right away. And then I was like, okay, so then they showed up in the routing table, they show up in the BGP table, and I was able to get some of the connectivity that I wanted to have with some of the other locations. I was able to get that to work as well, which is the whole idea here. So let me go ahead and flip over to the other screen, and we're going to go through basically what it is that I had to go do. As you can see, the ping is working. I have currently PC15 pulled up. PC15 is a customer 2 VLAN 210 endpoint, and I'm able to ping 10.101.32.11, which happens to be PC1. If I do a trace to 10.101.32.11 and I hit the enter key, we are able to get there all day long. So that tells me that I have reachability wherever I need to go, which is exactly what I'm looking for, right? So basically what I ended up having to do is on 9K1 and 9K3, let's go ahead and I'm going to go ahead and log in real quick. I'm going to do a show run VPC, and I ended up getting rid of VPC. I just turned it off, and if I do a show run interface port channel 13, this guy is in the current mode of shutdown. So I shut down the port channel, and everything's working there. If I do a show interface status, we're going to see that the 4 and 5 are currently in channel is down, right? And then we can see that E1/6 is currently in suspended mode, because if we look at show run interface E1/6, which happens to be our link downstream to this guy, I still have a channel group set up to it. So I really need to go ahead and pull that channel group command off, and then let spanning tree protocol to figure out which particular endpoint we're going to send traffic towards. But right now, 17 and 19 won't work because the port this connectivity up here between switch 8 and 9K1 and 9K3 is not set up currently. So I went ahead and I deleted the VPC. I shut down the peer link port channel between 9K1 and 9K3. And once I did that, I was like, okay, that's good. I was getting a lot of issues. Matter of fact, I can scroll back up. I was getting a lot of issues here, and I was like, what am I doing here? So that's when I went underneath the port channel. I went underneath here, interface port channel 13, and I shut it down. And then what I had done, let me go ahead and log back in here to 9K3. What I had to do was, let's go do show run pipe section route dash map. Underneath the route maps, what I had to do is I created a route map called direct customer 1 and then matching on the sub interface. Same thing with customer 2. And when I did that, that matches on these sub interfaces right here. If we do a show IP interface brief for VRF customer 1, we're going to see that there is this interface right here that's currently being used. Same thing with customer 2. So what I did was set that up to where it would allow me to match on those sub interfaces. And by matching on the sub interfaces, I was able to go through and advertise them into BGP directly. And I wanted to just redistribute this stuff in the event that, you know, there was other things to match on. So show run BGP. If we come down here, you can see that underneath customer 1 and customer 2, I'm doing a redistribute direct route map, direct customer 1 and direct customer 2. So that's all working the way that it should be. Because if I do a show BGP L2 VPN eVPN, if I come down here to the bottom, you can see that I have 12 right here, right, which is this link here, and I've also got 32. 32 is the other side of this. Now, what was happening was when I went over to 9K1, or I'm sorry, like PC14 and things like that, PC14 was able to ping, PC20 was able to ping because they're directly wired into 9K3. But anything that would need to use VXLAN for communication was not working. So when I went to 9K1 and I did a show BGP L2 VPN eVPN, I was like, I was missing prefixes, right? Things were not showing up the way that they need to. So underneath the connection here, I've got these prefixes being brought in. So this is going to be the subnet that is used to connect into the provider. So that's this subnet right here. And then 31 is this subnet over here connecting PE3 to PC1. That's where these routes come into play. And I was looking through the layer 3 VNI. I'm like, okay, things aren't showing up the way that they should be. Why isn't this working? And it was actually really frustrating because I was like, this should be working. And I was like, why is it not? So as I was going through and messing around with it, I had gotten to this point, and then I was like, okay, testing connectivity. So let's go ahead and actually grab spine 1. We're going to capture on E1/1 and get this guy. We'll do some ping tests just to prove to everyone that we are actually using VXLAN for encapsulation between the VTEPs, because now we've broken the VPC, so it should be 2 separate VTEPs, right? Go ahead and scoot this over. So if I pull this up and I bring this down, and we look at it from the perspective of, let's do PC13 here, because I have not tested this one out. Oh, I did. So 10, 101, 31, 11. I can get there all day long. Wonder why that's not showing up. So ping 10.101.31.11. It's like the Wireshark capture is kind of freaking out a little bit on there on me. But irregardless, that it does work, and the connectivity is there. So that also means that PC11 should be able to connect internally. So PC1, not anything else. Show IP route VRF C1 and C2. And we can see that everything's working. We can see the routes are being advertised. So if I was to come over here and ping, we can see that 10 to 10/24 and 10 to 20/24 are being advertised. So if I was to ping VRF C2 10.2.20. Let's say 16, that should also work. There it goes. And so the reachability is there. So I just went from PC1 to PC16. Now if I was to come in here and go ping 21 here, let's do a show IP route again. Now you'll see 16 show up in the routing table, right? So you're going to get host specific routes will show up in this guy's routing table because it's a new IP address being advertised. Now if I was to ping C1 and ping 10.1.20.21, that should also work. Might take it a couple seconds for it to trigger, but that works as well. Let's do a show IP route C1, and we can see C1 is coming across. So these things are working the way that we need them to because we've set the environment up to support that. So with that being said, let me go ahead and refresh this real quick because the links decided to go bye-bye. So that's basically where we're at with all of this. So let me go ahead and retry this capture again on E1/1. The cool thing about this is when you are playing around with these capabilities, that when things aren't working and you have to troubleshoot them, it gets you a deeper understanding of how all this stuff works. There we go. Now we're cooking with fire. So I'm going to go ahead and move this down to the bottom and then move this up. There we go. So let's go ahead and move this part down. And I'm going to go ahead and do those couple ping tests again. So from PC1, we will do a ping test to that guy. And we're going to see that that should have been seen. I'm not sure why we're not seeing that. We're seeing everything, which is kind of crazy that we're not seeing the ping packet. Anyway, if we do it again, a trace route VRF C1 to 10.1.20.21, numerically, we should see there's the UDP messages right there. Go ahead and bring this down just a little bit. And you can see that we are using VXLAN encapsulation. So it's not sure why the ping doesn't show up there, but if we ping from PC21 and I try to ping here, we're going to see all of that come across. For some reason the pings aren't coming through. No harm, no harm, no foul. But now one of the things that I want to do a quick test on, and I haven't tested this out, so I'm being cautiously optimistic. If we go to switch 9 and we come in here and we do a show IP interface brief, we do a show VLAN brief, we can see that we have VLAN 10, right? We want to test VLAN 10, so I'm going to come up here and type in interface VLAN 10. I'm going to give this an IP address of 10.1.10.9 because that's an IP address that I know that's not being used. I'll type in /24 and I'm going to type in no shut. So that should bring up this guy. And there we go. I'm going to go ahead and type in no IP routing. That's going to turn the routing capability off and type in IP default gateway will be 10.1.10.254. So we're going to be using the Anycast gateway to reach what we need to reach. So what I'm also going to do is telnet, or I'm sorry, we're going to say username is going to be Rob, privilege level 15, password is Cisco, and then line VTY0/4, login local, and then transport input all. So we should be able to telnet into switch 9. So the first thing to do is on PC1, come up here and do a ping to 10.1.10.9. See if we can reach it. And hopefully we will. Let me test from switch 9. Again, I haven't tested this out, so show IP interface brief. So we're going to ping to 10.1.10.254. Now the idea is to be able to ping this IB or ping from switch 9 and ping Nexus 9K1. So not sure why that's not working. Again, I haven't tested this out, but the goal of my test, oh, there's the ping right here. Now it's starting to work. Wait, 10.1.9. Oh, it tried to ping. There's the ping. It's attempting to ping, but it's not working for whatever reason. Like the Wireshark capture was a little slow. But if we go back to PC1 and I try to ping 21, not sure why that's not showing up here in the output. Let me, sorry, ICMP. Yeah, it's being, Wireshark is being a little bit weird here with its capture capability. But the main point that I wanted to make was we should be able to reach everything that we're trying to connect to, and that's really the big thing that needs to be understood. So if we go over here to 9K1 and show BGP, or I'm sorry, not show BGP, L2 VPN. We're going to show system internal L2 forwarder MAC, and we should see from VLAN 10, if we look over here on switch 9 and do a show interface VLAN 9, or interface VLAN 10, it should have a MAC address 0009800A, which if we look at 9K1, that was the duplicate MAC. So it's being learned. That's probably why we're having a problem with it, is because it's being learned. We're getting an update saying that 56 learned it, which is Nexus 5K and Nexus 6K. So, but we don't see it showing up in our table here. But if we look at Nexus 9K5, we go ahead and take a look at him real quick. Once the system has been sitting idly for a while, it sometimes runs really slow. So let's actually forget that. But that was a test that I had not validated yet. But regardless of the situation at hand, we do have reachability to our endpoints. And that's really what I wanted to make sure we had, is connectivity to those endpoints. And then we were using VXLAN traffic to get us from point A to point B. And that's really what I wanted to make sure that we had operational. Because then from there, we can scale this out as much as we want, make sure that we have the connectivity that we need to have in play. That's really the big deal here, is making sure we have that squared away. So with that being said, ladies and gentlemen, that's pretty much what I wanted to show you guys in this video. I had to break the VPC. Once I broke the VPC, I had to shut down the port channel connected over the peer link. Once I did that, I had to remove the interface loopback 0 anycast IP address, which is the duplicate IP on two different devices. Remove that, flap the loopback interface, then I flapped the VTEP, so the MVE interface. And once I did that, then I had 9K1 and 9K3 acting as independent BGP peers to the spines. So what that means basically is that anything that was being redistributed from 9K3 into BGP would then be receivable by 9K1. It's one thing when you have a AS path issue where you're getting something in from the same AS and you need to basically relax the AS path loop prevention mechanism by saying, you know, like whether that's a allow AS in or disable whatever other checks you can put into play there. When you're getting the same source IP, that's a little more tricky to deal with because it's the same IP. So breaking the VPC in this particular case was the trick. Now, the question so in that line of thinking, it's, well, what happens if I have a VPC that I'm peering to the provider with and I need to go through and propagate that routing information to other 9K leaf switches? Well, then it probably wouldn't make much of a difference because now what you probably would end up doing is setting up a connection from the VPCs down to the BGP peer that you're setting up to. Now, I have never done that before. I don't even know if it's possible. I haven't taken VPC that far. But if it's possible to turn an interface into a router interface with VPC and then do a BGP peering over the top of it, maybe a layer 3 gateway or like a layer 3 port channel, I don't know if that's supported or not. But that would be maybe one direction you could go. I don't know though. But if you have a VPC connection and you have an eBGP peering set up to it and you're advertising the routes, you could advertise it to other other leaf switches that might be in a VPC because the source interface IP address is going to be different. And that was one of the key differentiators. So with that being said, it is working now. I'm not going to take it any further than that because I'm not going to go down the rabbit hole of that. What I am going to transition though into is getting the network back to a stable setup. So if there's any outstanding things, I'm actually going to go ahead and come back over here and switch back to my topology. I'm actually going to shut down my MPLS VPN connectivity. I'm going to shut down the internet connectivity because we've tested that out. I'm also going to shut down 9K5 and 9K6 because we are going to be transitioning into the multi-site design. The multi-site design is going to allow us to test out multi-site connectivity. So I'm going to be shutting down a lot of the devices that we've tested through and made sure that they're working. I'm going to transition I'm going to get a single border gateway up and running. I'm going to go through all of that config. I have to get the other data center up and running and stuff like that. So as I go through all this stuff, it's going to take a little bit of time to go through, but multi-site is where I'm going to go next. Now there is a few other things. I'm looking at my list of things to cover. I still want to cover private VLANs. That'd be something that's in there. I don't know if I'm actually, my goal is to cover it. I had to test it out first. Same thing with using ACLs with private VLAN or with VXLAN, and then tenant routed multicast. That's one other thing that I have not dove into, but that's going to require a slight shift in how the topology is built. So what I'm actually going to probably end up having to do is deleting some of these PCs and replacing them with devices that can actually do multicast, and that'll be a separate topology where I'll actually label that tenant routed multicast, or TRM, and see how that plays out. But other than that, multi-site is the next one I'm going to go check out because I've covered pretty much everything else that I wanted to dive into. So multi-site is what I'm going to spend my time on and get that working. So I'm going to test it out, get it working, and if I can't get it to ping, I'll let you know. I'm not going to spend a ton of time trying to get it to ping, but I will go through the config guides, get it working, configure it the way that it's supposed to, and then we'll see exactly how this is going to play out. So with that being said, ladies and gentlemen, I want to thank you guys for hanging out with me in this video. Until next time, guys, take it easy.